Hi, I'm Martin Swetman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. Now, so far we've covered the published research from the original Firestone et al. Paper in 2007 through to the end of 2010 in the last video. And this time we'll cover 2011. And as you can see from this list, there's not so many papers were published this year, but there's a real doozy here, this requiem paper. That will need a lot of discussion and will be the focus of this video. So remember where we got to at the end of 2010. The Comet Research Group had published several papers that claimed to have found the geochemical signals at the base of the black mat of a continent-wide cosmic collision event that triggered the Younger Dryas mini ice age around 13,000 years ago, which in turn led to the demise, they say, of many species of megafauna and major changes in human populations. But their data, which had seemed convincing, has been chipped away by their opponents who, remember, are leading advocates of other theories for these dramatic changes, namely climate change and overhunting. Nevertheless, their data, the Comet Research Group's data for the magnetic grains at the base of the black mat, has been confirmed at least one site, Lubbock Lake, and also at Murray Springs, although the lead author of the paper that confirmed the magnetic grain data at Murray Springs, Vance Haynes, strongly denies this. He's wrong, and it's easy to see this. It's very clear the magnetic grain abundance at the base of the black mat at Murray Springs is a massive excess. It cannot be the accumulation of normal sort of background cosmic dust that falls to Earth all the time, which was his conclusion. But most significantly, remember, a layer of nanodiamonds, millions of times more concentrated than background levels, was discovered in the Greenland ice sheet, and it appears to be at exactly the right level in the ice, according to the oxygen isotope trace, to be consistent with the Younger Dryas boundary, so the beginning of the Younger Dryas period. In fact, using the oxygen isotope trace to date this layer in the Greenland ice is probably more accurate than a radiocarbon date, because the radiocarbon calibration curve exhibits high levels of uncertainty precisely at this time. So it's clear that a major cosmic event happened over Greenland. That's what that nanodiamond evidence tells us. The only real question is whether the black mat discovered across the rest of America and into Europe corresponds to the same event, or whether these are all small local events that happen independently, say within a few hundred years of each other. Now, this is important because if they're small, isolated events, they're unlikely to have led to the dramatic Younger Dryas climate shift, megafaunal extinctions, or human culture changes. Only a major continent-spanning event could really do this. Now, common sense suggests these signals from Europe into Greenland and North America are all connected and result from a single massive event with catastrophic global consequences. But showing that is beyond reasonable doubt is tricky. Now, also remember, this was discussed in the previous video, the raised iridium level detected at the base of the black mat. Now, that has so far not been confirmed. Only a tiny spike in iridium was detected by opponents of the impact theory. I suspect, however, that somehow there is a problem with their measurements, but we don't know this yet. So now let's turn to the first few papers in 2011. Okay, so here we are. Now, first, there are a couple of papers by the Mahaney Group, so a couple more papers adding to the ones from previous years. Now, all the papers from this group, the Mahaney Group, are of a similar nature, and I'll leave them until much later, but essentially they all support the impact hypothesis. They find the signals of a cosmic impact on mountaintops across several continents. Essentially, they find all the mountain ranges they look at are scorched in some way, and they date these scorch marks to around the time of the Younger Dryas event. But as I say, we'll come back to these papers in another video. The next paper by Anderson and Goodyear et al. Is pretty interesting. It's an attempt by the Comet Research Group to counter the claims of their opponents that the Younger Dryas event had no significant effect on the Clovis population of North America. So let's just find their paper. So they look at three indicators of cultural change seen in the archaeological records. First, they look at the abundance of these stone tools, which are essentially stone spear points. And they count how many of these different kinds of stone tool, which can be identified from their shape. So they count how many of these different kinds are found at different levels in the sediment, and then they can try to correlate that with the radiocarbon date of the sediments in which they're found. And so that the result that they use a database of archaeological finds, and this is probably the main conclusion that they come to. So we can see, first of all, it's clear that there is a dramatic drop in the number of these types of spear point that are distinguishable from Clovis spear points. Okay, so these are the Clovis spear points, and these are the different kind of spear point that follow at a later time. So there's a clear change in the number or frequency of these types of spear point. Now, this is a good indicator of a significant change in culture, the human culture across North America at the time. It tells us that there were changes in the human culture, with the later culture probably being less populated, but then it rebounds again, so the population decreases and then increases later. What it doesn't tell us exactly is when this happened. So we can't tell from this plot whether this change happened slowly in different places in North America at different times, or whether there was a sudden catastrophic change across the whole continent. And remember, it's generally thought that the Clovis population preceded the Younger Dryas event, and these other ones were afterwards. Now, to address this question of timing, Anderson et al. Add up the radiocarbon ranges of all the campsites in the database of archaeological sites for North America, and we can see their results here. And what they find from this summed probability distribution is that there appears to be a dip in the frequency of these campsites right near the origin of the Younger Dryas period, which is around about here. So it appears that we could correlate this change of spear points, or these stone tools, to this reduction in population that occurs at right about the beginning of the Younger Dryas period. However, they use exactly the same method here as Buchanan et al. From 2009, which we criticized heavily in the first video. And we criticized it because they use all the data from the database without sifting it, so without constraining the uncertainty in any of the data that's used. And so for that reason, because we criticize the Buchanan et al. Data, we have to criticize this method as well. So even though this looks to be a good indicator of this cultural change occurring at the Younger Dryas, beginning of the Younger Dryas period, we can't be satisfied with that. Fortunately, if you remember, Holliday and Meltzer, so last year in 2010, they did perform an analysis that did sift out the data, or did perform a quality check of the data to sift out campsites with very high radiocarbon uncertainties. And you remember that we saw from their data that there did appear to be a change that began because of the difference in the slope. If we draw a line, or try to draw a line through these points, there appears to be a change right about here, about the same time, about 10,800 BC. So regardless of whether we use all the data or whether we just use the higher quality data, there does consistently appear to be a change right at the beginning of the Younger Dryas period. So we can, from that, if we put all this evidence together, we can fairly confidently say that the change in Clovis to post-Clovis culture occurred quite likely right at the beginning of the Younger Dryas period, and it was a fairly quick and dramatic change. However, we don't know from this evidence what caused this cultural change. It could simply be a result of the dramatic shift in climate that occurred at the onset of the Younger Dryas period. We can't take from this evidence for a cosmic impact. However, if we eventually find the Younger Dryas mini ice age was itself caused by a cosmic impact, well, then obviously that becomes a prime candidate for the end of the Clovis culture as well. Okay, so the next paper in 2011 that we're going to look at is really interesting for several reasons. So here it is. We see the familiar names of Pinter and Dalton, who, among others, have previously written critical papers about the impact theory. Now look at the title of this paper, The Younger Dryas Impact Hypothesis, a Requiem. Now, as a scientist, whenever I see a title like this, my scientific hackles are raised. It's very likely these authors have an agenda, probably because they are some of the leading proponents of alternative theories like overhunting and climate change for the demise of the North American megafauna at this time. So straight away, because of this title, I am on the lookout for bias. I'm immediately suspicious of this work. So what's it all about? Essentially, this is their attempt to kill the impact theory. They go through all the primary evidence published by the Comet Research Group, like the magnetic grains and the nano diamonds, and they dismiss each line of evidence as being either not reproducible, or if it is reproducible, then they suggest an alternative reason for its existence. And in fact, their conclusions are neatly summarized by this table. I'll just find it. Here we go. So here they list each line of evidence put forward in favor of the impact theory. And they list whether the data has been reproduced or not, or whether it can be explained by other causes. And obviously, so in this column, they are saying that the data has been reproduced, but it's consistent with non-impact mechanisms. And here they're saying that the original data has not been reproduced. And these are all the different lines of evidence. And obviously, because there are no crosses in this column, which is where the claims are corroborated, then they dismissed the impact theory. So let's go through their table and see if their analysis holds up. Remember, because of the title, we should be looking out for bias in their interpretation of the data. Now, the first two items here were not actually mentioned in the original Firestone paper of 2007. These two things here, the particle tracks in archaeological chert and magnetic nodules in Tuscan bone, they were mentioned in a book in 2006 by some of the leading members of the Comet Research Group. I'll just find the book here. There it is, The Cycle of Cosmic Catastrophes. And as such, these lines of evidence were never peer-reviewed. So we can ignore them. We're not interested in these non-peer-reviewed lines of evidence. We're only interested in the research literature. The next item is fullerenes. Now, fullerenes are an unusual closed form of carbon. Now, the requiem authors dismiss this item because, as they say quite rightly, the fullerenes are found in ordinary soot. So they are not a good indicator of a comet impact. They are routinely produced by forest fires, for example. Now, the helium-3 evidence is also dismissed. So here, the issue is the relative abundance of helium isotopes trapped within these fullerenes, these closed forms of carbon. Now, I'm not sure it's quite fair to say, as they do, that the original evidence is non-reproducible, because nobody apart from the Comet Research Group has tried to reproduce this evidence. So probably there should be another column which is not attempted, but they don't have an extra column, so they just say it's not been reproduced, which is a little bit unfair. Okay, let's move on. The next entry is the iridium evidence, the iridium peaks at the base of the Black Gnat, and this is very interesting. Now, it has two crosses, probably because one attempt could not corroborate the evidence. It found no raised level of iridium at the base of the Black Gnat. Well, as we saw in an earlier video, another attempt did find an iridium spike, but it was far lower than the one claimed by the Comet Research Group, and it was dismissed as being nothing unusual. So they put across here observations reproduced but consistent with non-impact mechanism. The authors of this paper, I'll call them the requiem authors, are finally able to provide an explanation for this discrepancy between the levels of iridium found by the Comet Research Group and those found by their opponents. And basically, it's all a misunderstanding. That's what it comes down to. They correctly point out that different things are actually being measured here. The Comet Research Group, in the original Firestone paper of 2007, let's just go to their paper. Here it is. So they measured both the iridium content of the bulk sediment, and that's listed here in this column, and the iridium concentration inside magnetic grains from the base of the black net. And as we know, the magnetic grains form less than 1% by weight of the bulk sediment. So we can expect these measurements for the concentration of iridium in the magnetic grains. We can expect these two measurements to differ by about a factor of 100 or more, and they do. Now, the Comet Research Group accurately and clearly presented this data in this table and in their text. However, in their rebuttal paper of 2010, Paquet, okay, if you remember this paper from the last video, so in their rebuttal paper, Paquet only measured the iridium content of the bulk sediment and not the iridium concentration in the magnetic grains within the sediment. They then claimed that they could not reproduce the Comet Research Group's findings. Essentially, they were comparing apples with pears. So let's look again at their plot, which is what they use to dismiss the Comet Research Group's findings. So here they're comparing measurements for iridium in the magnetic grains, which are from the Comet Research Group, which are these symbols, with measurements from the bulk sediment, which include the magnetic grains at a level of less than 1%. Now, comparing them on the same plot is obviously wrong. They're completely different measurements. They should not be on the same plot. So at best, by comparing these two types of measurement, this is a simple misunderstanding. Now let's go back to the Requiem paper. So the Requiem authors, they point this out quite correctly, but in their text they attempt to place the blame on the Comet Research Group for misrepresenting their data, and nothing could be further from the truth. In fact, the mistake was made by Paquet et al., as I've just shown, by presenting that plot. So at best, the Requiem authors have misread or misunderstood the original data in the Firestone paper. Anyway, at least the discrepancy is now cleared up. We can see that the measurements, the data in these two different papers are actually completely consistent. But because of their likely bias, the Requiem paper authors suggested that this data is nothing unusual. So they place a cross in this column. So observations consistent with a non-impact mechanism. But that's wrong. In fact, these magnetic grains, because of their high concentration of iridium, are highly unusual, as pointed out by the Comet Research Group. They state quite clearly that the magnetic grains recovered from above and below the black mat layer have no iridium at all, or no measurable amount of iridium. Only the magnetic grains from the base of the black mat have this high concentration of iridium. So only the magnetic grains in the black mat are anomalous. Now, without some explanation for this anomaly, the Requiem paper authors' dismissal of the iridium evidence is quite unfair. All right, that was quite a complex argument about the iridium peaks, but fortunately the rest of these items are a bit easier to understand. The next item is enhanced radioactivity. Now, the Requiem paper authors correctly state that this data could not be reproduced by independent researchers. But they also state that enhanced radioactivity is not an indicator of a cosmic impact anyway, so its non-reproducibility is a moot point. The Carolina Bays item is a complex issue that I don't want to go into here. So these so-called bays are shallow depressions or lakes found across North Carolina and perhaps in other states too. Now, some researchers claim that they are secondary impact structures remaining or formed and then remaining by huge chunks of ice propelled thousands of miles from a Younger Dryas impact site by the power of the explosion. The standard view, though, is that they are simply formed by running water. That's consistent with the uniformitarian paradigm. Now, although I like the secondary impact idea, and especially the work of Antonio Zamora, whose videos you can also find on YouTube, and who has published research in peer-reviewed journals about this, It's really a question for the geologists to resolve, and therefore it's outside of my comfort zone. So I'm going to leave this item alone, the Carolina Bays, and move on to the next one. So next we have carbon, spherules, elongates, and glassy carbon. Now, these are all different forms of heat-treated carbon. Now, I agree with the Requiem authors that these are not good diagnostic indicators of a cosmic impact. So like fullerenes, these types of unusual carbon might be caused by natural wildfires. So here I think the Requiem authors are probably fine to dismiss this line of evidence as being consistent potentially with a non-impact mechanism. So now we come to another contentious item, the magnetic grains themselves. So these are basically the tiny iron filings that we've already discussed are enriched in iridium. Now we have seen the magnetic grain evidence reproduced at Lubbock Lake and at Murray Springs. But the Requiem paper authors, by putting their cross here, are claiming there is nothing unusual about these magnetic grains. Moreover, they also suggest the amount or abundance of these grains, which can amount to nearly 1% of the bulk sediment at the base of the Black Mat at Murray Springs, is nothing unusual. Now, once again, they're using the common strategy of claiming these magnetic grains are simply filtered out and concentrated by the Black Mat from the normal cosmic dust that falls to Earth all the time. But we know this is wrong. We already know these magnetic grains are highly unusual because they are rich in iridium, and the grains found above and below the Black Mat, which presumably are the normal background cosmic dust grains, are completely different. But the Requiem paper authors ignore this. Also, they don't provide any calculations to show that the abundance of the amount of the magnetic grains found at the base of the Black Mat is consistent with simply concentrating the background atmospheric dust. It would be easy to show this, if they wanted, with a simple calculation. Simple calculation would multiply the sort of background rate of dust accumulation by a period of, say, 100 or 1,000 years to represent the accumulation at the base of the Black Mat. But they don't bother to do this. And in fact, it's obvious from the concentration of magnetic grains, which is nearly 1% of the bulk sediment at the base of the Black Mat at Murray Springs. It is a massive excess and cannot be explained away like this. So this cross should really be in the corroborated column. So now let's move on to the magnetic microspherules. So these are more spherical types of magnetic grains, and they're hard to define properly. So I agree that these are not a good indicator by themselves of an impact, cosmic impact. Then we have the so-called megafire products. So again, I agree that these are not diagnostic of cosmic impact, unless the amount of charcoal and other fire byproducts is far in excess of what could be produced by a normal wildfire. And as yet, this is not clear. So for the moment, we have to accept this cross being in this column. So now finally we come to the nanodiamond evidence. Now the Requiem paper authors here are using the results from the recent paper by Tyrone Dalton, who's an author on this Requiem paper. So his paper in 2010, and he contested the interpretation of the electron scattering plots of the Comet Research Group. So putting a cross in this column is fair enough on that basis of his earlier paper from the previous year. However, what these authors didn't know when they submitted their Requiem paper is that a layer of nanodiamonds had just been discovered in the Greenland ice sheet at a level in the ice that is perfectly consistent with the Younger Dryas boundary. So at the time they wrote this paper, the Requiem paper, the cross is fine here, but by the time their paper is published, this cross is incorrect. Therefore, because of the Greenland discovery, this cross should probably be moved to the corroborated column. So to sum up, the Requiem paper seems to have some clear biases. These authors have no explanation for the enriched iridium in the magnetic grains, nor for the massive excess of magnetic grains at the Younger Dryas, at the base of the Black Mat, the Younger Dryas Black Mat, which has been confirmed even by some of the Comet Research Group's most ardent critics. And by the time their paper is actually published, it's dead in the water because of the nanodiamond discovery in Greenland, which preceded its publication by several months. Okay, so now I'm going to move on to the final paper of this year, which is also a very interesting paper. So this is a paper which includes as co-author Philip Clays, who, if you remember, was previously a critic of the impact hypothesis. Now, this paper actually confirms discovery of a nanodiamond-rich layer at the base of the black mat at a site at Lommel in Belgium. And the authors are very clear that in their view, these are definitely nanodiamonds and not anything else. But they do not find the more exotic form of nanodiamond known as Lonsdaleite. So now we have confirmation of nanodiamonds at the Younger Dryas boundary in the Greenland ice sheet and in Belgium, even by researchers who are highly critical of the impact hypothesis. So probably we can now begin to think that probably the earlier report by Dalton et al. That dismissed the nanodiamond evidence from North America, probably they've made some mistakes somewhere. Perhaps they didn't use the right soil samples, for instance. But we can't know. We can't know that. We can't know if they did make a mistake. But that's what we are beginning. It'd be reasonable to suspect. But once again, the authors of this new Lommel paper don't conclude in favor of the impact theory. In fact, they're as negative as they can be within the limitations posed by their own data. Their title says that although nanodiamonds have been confirmed at the Younger Dryas boundary, they're not diagnostic of a cosmic impact. They cite the lack of the exotic Lonsdaleite form of nanodiamond and the fact that the bulk sediment from this black mat layer does not show any excess iridium as reasons for not confirming the impact theory. Now, this kind of approach to science irks me. You see, science is not about proof. Proof is reserved for pure mathematics. Science is about finding the most likely explanation for observations. And because they don't present any alternative explanation to the cosmic impact theory for the accumulated data from a wide range of papers, including their own, and the cosmic impact theory looks to be the only reasonable explanation of this data, their title is, in my view, not a very good scientific title. In fact, in my view, a better title would have been Confirmation of Nanodiamonds at the Lommel Black Mat, Belgium, offers support to the Younger Dryas impact hypothesis. Okay, but they are trying to put the most negative spin on this that they can. So let's summarize where we have got to by the end of 2011. The Comet Research Group's findings were initially criticized as being preposterous and not reproducible. A confirmation of their results for a massive excess of iridium-rich magnetic grains at two sites in North America and nanodiamonds in the Greenland ice sheet and in Belgium take the impact hypothesis to a point where it's almost proven. Based on this evidence, it would be highly surprising if the impact theory were eventually found to be false. It is now quite clear that human populations in North America, at least, were significantly affected by this. Okay, if you like that, then stay tuned for the next video, which will follow in a couple of weeks, and take a look at my blog, martinsweatman.blogspot.com, and my book, Prehistory, Decoded. Now, the next video will look at 2012, and that's an eventful year for the impact theory research, and not least because Mark Boslow, a computational physicist specializing in impact physics, joins the debate and has a lot to say.